Hello, everyone. My name is Jonathan Salvador. I'll be doing a presentation on the gas laws. I'm using a program called Screencast-O-Matic, and because of the size of the recorded screen, I won't be able to use much animation. Otherwise, if I blew up the screen, you wouldn't see anything. So I'm keeping it small and be changing the screens by hand. But anyways, the gas laws. Have you ever wondered how a hot air balloon stays up in the air, or how it comes down safely, or how a scuba diver and a fish, for that matter, can go under the ocean and survive at very high pressures and temperatures? Well, the gas laws explains these things. So, have you ever gone fishing, and if you bring up a fish too fast, you'll notice that it gets bloated, something like this picture that this picture is displaying. Eyes bulge out, their organs, and that is a intestine or a stomach popping out of the fish's mouth. And the reason for that is because the balance between pressure, temperature, and volume have all been imbalanced. And so by studying gas laws, we can make sure this does not happen. This video that I will not play will explain all that thing. It's about 7 minutes long, but you can play this video at your leisure. What we're going to do is we're going to create a foldable, and we're going to use 3 sheets of construction paper and fold it in such a way that we can take notes on all the different gas laws that we're going to be covering in this unit. Today we're only going to do Boyle's and Charles' law. And so after we fold it, we're going to put some notes in there so that you can study from them. All right. Each page will correspond to a different gas law, and each page will contain a definition, a formula, and a sample problem so you can understand how to solve gas law problems. After all, the test is all about solving problems, correct? So here we go. On the front cover, there's pieces of information that you must know. First of all, there is something called standard pressure, and that standard pressure is 1 atmosphere. And we can write that on the front cover of our gas law so you can readily look at it. We also have something called standard temperature, which is 273 degrees Kelvin. And I know you've probably heard of degrees Celsius, but degrees Kelvin is also a type of temperature. And to convert from Celsius to Kelvin is easy. All you got to do is add 273, as these 3 points tell you. Okay. All right. Also, pressures comes in different units, and some are pascals, torr, millimeters of mercury, and pounds per square inch. That's what most people have heard. So I've given you some equivalent statements or equivalent values so that we can, so when you see them in problems, you can recognize whether they're a pressure or temperature and volume. So the very first law we have is called Boyle's law. And this is what dictates of how a balloon reacts. So let's go into it. All right. So here we go. So Boyle's law. Here's a definition. You're going to write this on the second page after the cover, and you're going to write down the definition. So Boyle's law states that the volume of a fixed amount of gas held varies inversely with the pressure. So volume inversely is inversely proportional to pressure. So as pressure goes up, volume goes down, and vice versa. So that's how a balloon. So if you squeeze a balloon, the volume is going to get smaller because you're squeezing a balloon, but the pressure is going to get a lot higher. So the formula for this is called P1V1 equals P2V2, where the 1 means the initial, the start value, and the 2 is the final value. So keep that in mind, and we'll get into that a little bit later. All right. So Boyle's formula is this. So P1V1 equals P2V2. P equals to pressure, and V is equal to volume. Now, the problem with most students in previous classes is they don't recognize when they read the problems what is a pressure and what is a volume. So I put here the types of units. So the numbers in the units in the problem will tell you whether something is a pressure or a volume. So if you see ATM or PSI or torr, millimeters of mercury, or kPa or PA, you know that's a pressure. And if you see units like milliliters or liters, which you're more familiar with, then you know it's a volume. So let's practice that. So here's an example. The volume of a gas at 99 kilopascals is 300 milliliters. If the pressure is increased to 188 kPa, what will be the new volume? So using Boyle's law, we can solve this. Now, if you look at this problem, the numbers you see are very specific. You see 99 kilopascals. kPa is a pressure. So you know that's a pressure. 300 milliliters is, you see milliliters, so that must be a volume. You also see 188 kPa, which is also another pressure, and they're asking for a new volume. So basically, you're solving for V2. So let's see what that looks like. All right, so again, P1 is equal to 99. That's the start value. They're going to change the pressure to 188 kPa. The volume 1 is 300 milliliters, and they want you to find out what V2 is. Well, all we got to do is a little algebra, and we can figure out that V2 is equal to P1 times V1 divided by V2, or P2. So by just doing the math, putting in your calculator, you're going to figure out that it's 157.98 milliliters. And that's basically it. It's basic algebra. It's nothing hard. I know a lot of people are scared of math. Most of my students are. But if you just use the formula and write down exactly what each value is, all you got to pretty much do is, like my old teacher said, plug and chug. Okay? All right. So now we get into Charles' law. And Charles' law is the reason why hot air balloons can go up and come back down. All right. So again, turn to page 2. You're going to label that Charles' law. And then the definition for Charles' law states this: the volume of a fixed amount of gas is proportional to the temperature. So what does that mean? Well, that means as volume goes up, temperature goes up, and vice versa. So basically, if you heat a gas up, the volume of it gets bigger. And we're going to do some demonstrations at the end of after this lecture, and you're going to see how this works in real life. So again, here's a formula. It looks very similar to Boyle's law, but it's actually Charles. And I actually made a mistake there. It is Charles. So V1 times T2 equals V2 times T1. Again, the 1 is always the initial, and number 2 is always the final. Okay. But here, we're using temperature. And there's a thing about temperatures in these kinds of I'll go back. Temperatures in Charles' law have to be in Kelvin. They have to be in Kelvin for you to do any kind of math. So again, V stands for volume, and its units are always the same, milliliters or liters. And temperature in units is either going to be degrees K or degrees C. But if they give you degrees C, you must be able to convert. So to get to Kelvin, all you got to do is add 273 like we said earlier. So let's do some practicing. So a gas at 89 degrees C occupies a volume of 0.67 liters. At what temperature will the volume increase to 1.12 liters? Well, let's look at what we have here. Well, a gas at 89 degrees C, well, there's a temperature, occupies a volume of 0.67 liters. So there is your volume. Okay. At what temperature will the volume increase to 1.2 liters? So they changed the volume from 0.67 to 1.12, which means that 0.67 is V1 and the 1.12 is V2, and they want you to find out T2. So again, let's look at that. V1 is 0.67 liters, V2 is 1.12 liters, and of course, T1 is 89 degrees C, but you have to put it in Kelvin. So I added 273 here, so that makes it 362 Kelvin, and we're looking for T2. So again, we're solving for T2. So if we do a little algebra, the formula we're going to use is this. It's T2 is equal to V2 times T1 divided by V1. So all we got to do is plug and chug. Very simple. So 1.12 liters times 362 Kelvin divided by 0.67 liters. That leaves us with 605.13 degrees Kelvin. And all the gas laws, as we get into it, work the exact same way. So all you got to do is know your formula, know a little algebra, and just figure out what you need so to solve for, and just arrange your formula accordingly. Like I said, I can solve for any one of these depending on the problem, but all of them are the same way. Okay. We will now complete 2 demonstrations. So if this was a real class, I would definitely set up a lab and you guys would do a hands-on demonstration or an experiment, if you will, on how Boyle's law works and how Charles' law works. The Charles' law, we would heat up a balloon on top of a beaker so that it blows up, and you can see that as the balloon grows. And for the demo for Boyle's law, we would use, they call it a diver, which we use a 2-liter bottle and a little test tube in the middle of it to see how it goes ups and downs by squeezing it. So you'll see it visually. It's a really good demonstration. Well, it's about it. Is there any questions? If there are any questions, I'm glad to answer them. So in closing, remember Boyle's law uses pressure and volume, and Charles' law uses volume and temperature. So thank you for your time. Tomorrow we will talk about Gay-Lussac's law and the combined gas law. And of course, we eventually will get to the ideal gas law, which a couple of years ago with the Deflategate and the New England Patriots, that was all the rage, was to talk about the ideal gas law. Well, thank you for your time. I appreciate it. Have a great day.